Hello, hello, hello. Welcome back, guys. Today is Monday, the 1st of June, and today I'm going to be doing June 2023 OCR MEI Paper 2 for the A-Level Math syllabus. Paper 2, Paper 3, the comprehension one. Because I know that there's not a lot of content out there when it comes to that specific board. And because I think Paper 3 is just the most interesting one I've seen. It feels like the one you kind of prepare for the least. Papers 1 and 2 felt like more standard, but Paper 3 looked fun. And so I was like, all right, let's throw out a couple more Paper 3s in the time we have before you finish. Final 3 weeks now, and so you guys are completely free. So hopefully you guys are looking forward to that. I'm feeling a lot more calm now that half term is over, but that probably means you guys are now super busy actually taking the exam. So good luck. Keep calm, do your best work. We'll just get you through to the other side. You'll be surprised how quickly these final 3 weeks go. Now I imagine, well, actually I know I've got a hard stop at 1, so I'm not going to go too crazy with the chit chat. I'm just going to go straight into things and see how I do. Because I remember last time I solved it quite quickly. So I'm curious to see if this is going to be an equally quick paper. In theory, it's 2 hours, but you know. Okay, so I'll have a calculator at the ready as well, just in case I need it. I'm not as good with the CG50, but I know, well, I've still got the CG50 on hand. And like, as I progress, I think I'll get better at the little tips and tricks for all the different little calculators that I'll be able to demonstrate. But for now, let's just take it as given. Right. Let's get into it. So question 1, section A, I know I'm happy with. This is usually fairly straightforward. Obtuse angle is such that thing, so it's obtuse that find the exact value of cos. Well, let's draw a right triangle. So if there's a theta there such that opposite is 2 and that is root 3, then I think by Pythagoras that makes that 3. Let me just check that real quick. Root of 13 minus 4. Yeah. So that becomes 3. So cos theta, in theory, would be 3 over root 13. But remember that it's obtuse, which means it's actually going to be negative. Because if it's obtuse, then in your cast diagram, you know, sine is positive, cosine's negative. Or alternatively, if you don't like that method, you could instead say that cos squared theta is 1 minus sine squared theta. So it's 1 minus 4 over 13, which is 9 over 13. So cos theta would be plus or minus 3 over root 13. And in this case, you choose the negative for the same reason, that the cosine will be negative in that region. And why not? Let's rationalize, just to show all of our skill. Okay. Question 2, we have a straight line. Copy, sketch the graph of y equals the modulus of that thing. Okay. Well, that's going to be positive when it's positive. You would obviously do this with a ruler, but then it goes like that, sort of V-shaped. And solve where this thing is less than 3. I would always draw it on, so that's y equals 3. And so what we would have, I always consider the 2 branches, right? So this branch would be y equals 5 minus 2x. And this is the branch where it's been flipped. In other words, multiplied by minus 1. So this would be y equals 2x minus 5. So let's solve these both. So 5 minus 2x is equal to 3 when 2 equals 2x, so x equals 1. And on this side, 2x minus 5 equals 3 when 2x equals 8, so x equals 4. So that there is 1, that there is 4. And the modulus is less than 3 everywhere in between, so it's x being between 1 and 4. Ooh. Oh, sorry, that was 2b. Oops. I'll give it, it's fine. 3, find the value of k such that this thing is true. Well, let's work on rationalizing. I'll In fact, let me as well give myself a bit more room to work. So here, 1 over root 5 plus root 6. What we do is we multiply top and bottom by the thing on the bottom with the sign changed. Okay, so that would be root 5 minus root 6 all over 5 minus 6, which is minus 1, so that becomes root 6 minus root 5. 1 over root 6 plus root 7, similarly. Root 7, let's multiply by root 6 minus root 7. So root 6 minus root 7 all over 6 minus 7 would be root 7 minus root 6. So if I add those together, the left-hand side is going to be equal to, because the minus root 6's are going to cancel, it would be root 7 minus root 5. So in other words, we know, now let's consider the right-hand side, which is k over root 5 plus root 7. And again, we can multiply this by root 5 minus root 7 on top and bottom and get k into root 5 minus root 7 all over 5 minus 7, which is minus 2. So in other words, I'll say it's k over 2 into root 7 minus root 5. And we know this thing is equal to the left-hand side, which is 7 minus root 5. So in other words, k over 2 must equal 1 and k equals 2. And that'll be very easy to verify later on. So find the coordinates of the points where this thing crosses the x-axis. All right, so if we've got a cubic, but we start with a kind of trial and error. I love this technique, though. So this is going to be done by factor theorem and algebraic long division. So we do need to do trial and error, but you only need to consider factors of 6 in the plus and minus. So 1, 2, 3, 6, minus 1, minus 2, minus 3, minus 6. It will never work with x equals 4 or x equals 5 because they do not go into 6. And that's a very helpful trick, by the way, when trying to work out what one of the factors is. It helps sort of narrow down the possibilities. So here, the first thing to check is f of 1. So that would be 1 minus 2 minus 5 plus 6. Oh, look at that, it equals 0, which means that x minus 1 is a factor. So that means now I can do algebraic long division. I think there are other methods to this. If I'm going to do this, I'll do it. Well, first of all, you can do it by inspection. That's my preferred, so I'll demonstrate it for those who like it. That would be x minus 1 into, that's x squared. Then I'd be left with minus x squared. So I need another minus x squared, which comes from x times minus x. Then I've got minus 1 times minus x is plus x, but I need to get to minus 5x. So I need another further minus 6 lots of x. And so that's that. That's factorized. X minus 1, x minus 3, x plus 2. Now, a lot of people don't like inspection, so you could also do your long division. My preferred for that is the bus stop method and not the other one. I really need to get, because none of my students have ever required the other one. But I suppose in theory, if I'm going to be doing this for the internet, I should learn to do it how everyone learns how to do it. A big issue people have with this technique is remembering the sign errors. So that's negative, negative, which turns that into a plus. So that becomes minus 2x squared plus x squared, giving you this minus x squared. A lot of people would turn that into minus 3x squared. Do not be that person. So similarly here, that's minus turns that into minus 6x plus 6. So minus 6x plus 6, and that subtracts for 0. Cool. So that's another way you could have got the x squared minus x minus 6, and then you fully factorize. Now, the second you think you're done with the question, reread the question to make sure you've actually finished. here I have not actually finished because it doesn't want me to solve to do that. It doesn't even want me to solve for x. It wants the coordinates of the points where it crosses the y-axis. So it crosses the y-axis when the function is 0. So when this guy equals 0, which means that x is equal to 1, x equals 3, x equals minus 2. Now the full coordinates, hello. Full coordinates are 1, 0, 3, 0, minus 2, 0. And those are your points. All right, question 5. So we have that curve. Find the equation of the tangent. So we got tangents and normals. This is immediately making me think of differentiation in order to find the gradient. So dy dx is equal to 3x squared minus 10x plus 6. And when x equals 0 at the origin, dy dx is equal to 6. And therefore, we can say that y minus 0 is equal to 6 into x minus 0 from the equation of a straight line, or simply y equals 6x. Similarly for b, our dy dx is the same, 3x squared minus 10x plus 6. And we want this at the point when x is equal to 1. So when x is equal to 1, dy dx is equal to 3 minus 10 plus 6, which is equal to minus 1. The perpendicular gradient is minus 1 over the gradient, which is, in this case, 1, which means that y minus 2 is equal to 1 into x minus 1. In other words, y is equal to x minus, no, lies. See, I got complacent. I thought I was in the easy bit. And so I skipped steps and I didn't get it right. So I'm just going to not make that mistake. So y equals x plus 1 is the normal at that point. Find the coordinates of the point of intersection of those two lines. Well, that was when y equals 6x and y equals x plus 1. So we can just set them equal to each other to find the point of intersection. 5x equals 1, x equals a fifth. And therefore, because that lies on both lines, I can plug it in to this one nice and simply and say y equals 6 over 5. So the coordinates are 1/5, 6/5. Okay, we've got some funky quadrilateral. Find the coordinates of the following midpoints. That is so tedious. And it's only 2 marks. And then verify that PQRS is a parallel. Wow. All right. So here, find all the midpoints. Well, the midpoints are done by just simply taking the averages of the x and the y's. So P is going to be the average of K and L. So I'll demonstrate one of them, but then just sort of, so it's the average x and then the average y. So that is going to be equal to 1/2, 0. Q, actually go on, I'll just write the whole thing. Q is 5 plus 6 over 2 minus 1 plus 2 over 2, which is going to be 11 over 2, 1 over 2. R is 6 plus 2 over 2 and 2 plus 5 over 2. So that's going to be equal to 4 and 7 over 2. And S is minus 4 plus 2 over 2 and 1 plus 5 over 2, which is minus 1, 3. So we found PQRS. Verify that PQRS is a parallelogram. So we have to know that the opposite sides are, so it has 2 sets of parallel sides. So in other words, we need to show that PS is parallel to QR and SR is parallel. So let's kind of do this in vectors, I think is what I'm saying. So let's get the P to S vector. Or rather, no, let's do it the other way around. Let's do P to Q. Well, in order to go from P to Q, I have to add 10 over 2, which is 5 and a half. So that's that vector. QR, I need to go minus 3 over 2 in the x. And I need to go plus 6 over 2, which is plus 3 in the y. Let's do S to R in that order, because I expect that to be the same vector if it's a parallelogram. So to go from S to R, I add 5 in the x, and I add a half in the y. And I've done QR, so I need to now do PS. And to go from P to S, I go minus 3 over 2 in the x. And I go plus 3 in the y. So therefore, opposite sides. So it's not. So if they were multiples of each other, that shows that they're parallel. But because they are identical vectors, it shows that they're parallel and equal length. So opposite sides are parallel and equal length. Therefore, parallelogram. Okay. Cool. TVWX is a quadrilateral. Points A and B, divide that into 3 equal parts. C and D, divide that into 3 equal parts. Okay. So T to A is A. So what I would do is I would draw on all my local vectors just so I don't get lost. Okay, so show that. So let's work on what WX is. What I do with vectors is I always draw a good clear path before I do anything else. So that would be WV and then VT and then TX along vectors that I know. So WV is minus 3C, VT is minus 3A, and TX is plus 3B. So that's equal to 3 into minus A plus B minus C as required. Good. Verify that AH is parallel to DE. Well, that will mean that AH is a multiple of DE. So let's find them both. AH, again, good pathing along known vectors would be AT plus TH. Now, strictly speaking, these should be underlined because they're vectors. So I'll be good. I'll be diligent. So AT is minus A, TH is B. All right, let's also do DE. So DE is, well, now, hold on a minute. So WX, the whole of that, is 3 lots of this thing. So going along from W to X, that should be minus A plus B minus C. That should be minus A plus B over minus C. And that should be minus A plus B minus C. And again, every local vector, it means every time I see an arrow, I know it's only going from the 2 points on immediately either side of the arrow. So I just never, because if I drew an arrow and went, oh, that's minus 3A plus 3B minus 3C, I wouldn't know between what points that arrow was. So for me, I have to know that an arrow only exists between the 2 immediate points, so I never have any confusion over what my symbols mean. So here DE is DW plus WE. So that's going to be C plus minus A plus B minus C. The minus C is going to cancel, and that is going to be minus A plus B. AH equals DE, therefore parallel. So writing them as explicit multiples of each other, and in this case, that's a multiple with a scale factor of 1. Similar procedure here. Let's find BC. BC is going to be A plus C because it's BV plus VC. In fact, let me just be really good. So it's BV plus VC. So it's going to be A plus C. And again, let me be really good. And let me just underline my stuff like you should. And GF is GX plus XF. Now that matters because I'm about to go against the arrow. So that's B plus, now XF goes the other way. So that's plus A minus B plus C. So that will be equal to A plus C, where again, BC equals GF, therefore parallel. Okay. Okay, I imagine we're not done yet. Oh, we are done with that. Okay, cool. So here, this is immediately looking like radian measure. A wire 10 is bent to form the perimeter. Okay. So what we know, therefore, is that 2r plus r theta, because this length here is r theta. So r plus r theta is the perimeter, and that equals 10. Determine the maximum possible area. Well, the area is a half r squared theta. So what we're going to do, this is a classic optimization problem. We are going to eliminate theta to get the area in terms of just r, and the maximum is when the differential of that is 0. So in other words, making theta the subject of this formula, r theta equals 10 minus 2r, and theta equals 10 over r minus 2, therefore. Now, or rather, let me be even more particular. Okay, so A is equal to half r squared theta. So it's r squared over 2 times this theta. So an r is going to cancel there. So it's going to be a half into 10r minus 2r squared, which is 5r minus r squared. So that is A in terms of just r. So now dA dr is simply 5 minus 2r, and that will equal 0 at max area. So 5 equals 2r, r equals 5 over 2, and the maximum possible area, plugging that back into the area formula, the area is 5 times that 5 over 2 minus that 5 over 2 squared, which is, so 5 answer minus answer squared, 25 over 4. And that will be the maximum area. Now, the second you think you're done with the question, reread it. It says, deduce the maximum area, showing that it is a maximum. I'm not yet finished. I need to take the second differential, which in this case would be minus 2. And because minus 2 is less than 0, it means that the gradients around that point are decreasing. So it's about to start tipping down, therefore it's a maximum. Okay. Question 8. A circle with center A and radius 8, and a circle with center C and radius 12 intersect at points B and D. This is interesting. Okay. So let me kind of So that would be A, that would be C, that would be B, that would be D. That distance from A to B and A to D would be 8. That distance from B to C and D to C would be 12. So it's going to form a kite. The quadrilateral has area of 60. I can also draw the line connecting them up. And so this forms a kite, certainly. The quadrilateral has an area of 60, which means the area of each of those triangles is equal to 30. By symmetry. Well, that does get interesting because we want to work out AC, and I think we get there from here. So that theta, because remember, the area of a triangle is a half AB sine C. So the area of the triangle is 30, is a half times 8 times 12 times sine C, or in this case, sine theta. Now you'll notice this is not like with the previous questions, I was like, oh, this is the procedure. This is the first one where I've had to sit down and really think and work it out. So I'm going to, hopefully you can be justified in my reasoning that that is a kite, and by symmetry, we can split a line down the middle and it will create two triangles of equal area. So in this case, that would be 8 times 6 is 48 sine theta. So we know that sine theta is equal to 30 over 48, which is 5 over 8. Now, we are going to find AC by the cosine rule, but in order to do that, we need cosine. And I'm going to use what I did at the start, actually. So cos theta is 1 minus sine squared. So it's 1 minus 25 over 64, which is 39 over 64. So in other words, cos of theta is plus or minus, depending on whether the angle is acute or not. So it's going to be plus or minus root 39 over 8. So we're going to solve the cos rule twice, once for each of those values of cos. Or rather, so I'm going to start this over here, actually. So AC squared equals 8 squared plus 12 squared minus 2 times 8 times 12 times cos theta. So that's 64 plus 144 minus 2 times 8 times 12 is 192 cos theta. So 64 and 144 gives me my 208 minus 192 cos theta. And AC, so it's never going to be the negative square root because the length has to be positive. But it does mean that the cos theta can be plus or minus. So it's going to be the root of 208 minus 192 into plus or minus, what was it, root 39 over 8? Yeah. So 192 divide 8 is 24. So in other words, it's root of 208. Hold on, let me make that cleaner. So it's the root of 208 plus or minus 24 root 39. So root of 208 plus 24 root 39. Well, actually, I'll do the negative first. So that's equal to 7.62, or it's equal to 18.92. So those are my two possible values of AC. That was a legitimately difficult question. So no worries if you had to kind of skip that one. But this is much more standard. And this is why I advocate for multiple passes. If you find yourself getting stuck in the mud on 8, don't spin your wheels, just move on, bank the easy questions, bank the easy marks, and then come back to it. Okay, so let me work out what's happening here. Okay, so the annual electrical energy produced using solar panels is modeled in that fashion, where P is the amount of electricity produced and T is the time in years. Okay, so when T equal, in the year 2000, T equals 0, which means P equals 0.3. And when T equals 9, T is the time in years after the year. Okay. P equals 0.3 e to the 4.5, which is e to the 4.5, 27.0. Give a reason why the model is unlikely to be suitable for predicting annual amount of electricity in the year 2025. So it doesn't go on forever, basically. Model predicts infinite growth, but in practice, limitations on space and cost or something. So instead, it could look like this. Explain how the graph shows that the alternative model gives a value for the amount of electricity in 2009 that's consistent. Well, when T equals 9, P equals, well, it's roughly 25. Which is close to 27. So they agree. So in D part 1, now in the real thing, by the way, I would say close to 27 and then restate it in the form. So therefore, the value from the graph is close to the value from the original model, so they're consistent in the year 2009. I would probably write a lot of stuff just to make sure I definitely lock down that mark. Sketch the gradient function. Well, the gradient is 0 there and it's 0 there. Oh, wait, no, lies. I need to, whoop. How am I going to do this? So I'm going to have to zoom out here and drag across here. So actually, and I'm going to have to zoom out of this one as well. But it's okay because the graph is still going to be clear. I know the gradient will be 0 at 25. Sketch the gradient function. So it's going to be a maximum. I don't know what it's going to be a maximum of, but it kind of doesn't matter. By symmetry, I think I would expect it to be peaking somewhere here, and it kind of looks like it's going to be doing something like this, kind of symmetric. Something like that. And the real thing I think I would, well, first of all, I wouldn't break off there. You should do it in one continuous motion, but I would want it to be more symmetrical. I should have, I mean, realistically, for the purposes of this, it was fine, but I want to do it as true to real life as possible, and I would not be satisfied with that in the real thing. Nope. So it starts off flat. I messed it up. Just pretend it was fine the first time. I just some sort of generally symmetric curve that I can't really do right now on this pad. State the approximately the value of t at the point of inflection. Well, it's going to be roughly halfway in the middle, so I'll say 12.5, or t equals 12.5. Interpret the significance of the point of inflection in the context of the model. Now that's where things get more interesting. So in the context of the model, so the point of inflection is when it goes from, so it's always increasing, but it's when the rate of increase stops increasing. So it's when it starts to increase with, so it's when P begins to increase with a decreasing rate. State approximately the long-term value of the annual amount of electricity. Well, that would be this guy, that would be 300. And in fact, let me make sure, 300, and 300 means megawatt hours. So because this is a model, I want to make sure. Yeah, so for instance, this just said value of t. It didn't ask for the year. But in theory, I could have said that was, 2012. But here I want to make sure I'm doing it in terms of the model, which means it's not just 300, it's 300 megawatt hours. So we're given this thing. Okay, I'll take that as given. And so otherwise, prove this nonsense. Huh. Is this going to be, guys, I think this might be really fun. So let's say in this model, so what I'm seeing here, hence means use that, which means I'm going to have to form either the right-hand side or the left-hand side in order to substitute. So it looks like I'm going to want to form the right-hand side where x is equal to sine theta and y is equal to cos theta, which means I want to form a 3 sine 4 cos squared plus a 3 sine squared cos 4 term, which is incentivizing me to look here, split that out into a double angle formula, first of all, so that I can form that, get that all on one side, and then equate this thing equal to 1. So that's just immediately what I'm seeing here. That's going to be how I kind of go about this. So let's consider sine squared of 2 theta. Well, that's going to be sine of 2 theta all squared. And that is going to be 2 sine theta cos theta squared, which is going to be 4 sine squared cos squared. Let's plug that in. So sine 6 plus cos to the 6 is 1 minus 3/4 of that guy, which is 1 minus 3 sine squared theta cos squared theta. Huh. So it's sine 6 plus 3 sine squared cos squared plus cos to the 6 equals 1. But that isn't this. Sine of 2 theta is 2 sine theta cos theta. You square that up, you do get 4 sine squared cos squared. You multiply that by minus 3/4, you do get minus 3 of that thing. But that's not what I want. How? Listen, guys, okay, this is going to be utterly insane right now. But hear me out. Hear me out. What I'm going to do, because again, I know what I want. right? I know I want sine 6 theta plus 3 sine 4 theta cos squared theta. In fact, let me move this across because I need some working space now. So I want that and 3 sine squared, sorry, not x. So this step is insane, which is why I really want you to show you not just what to do, but how I'm getting there mentally. So this is what I want. This is not what I have. This is close to what I have, but I see I can get there by introducing new sine squareds and cos squareds. So I'm going to do something utterly insane. I am going to take this guy in the middle. Sorry, there was meant to be a theta there. Oops. And I'm going to multiply him by 1. And the reason why I'm going to multiply by 1 is because I can replace that 1 with a sine squared plus cos squared. Now, if I multiply that out, I get sine 6 theta plus 3 sine 4 theta cos squared theta plus 3 sine squared theta cos 4 theta plus cos of 6 theta equals 1 as required. And now I can say x equals sine theta, y equals cos theta, and therefore this thing is simply sine squared theta plus cos squared theta cubed equals 1. Which is just 1 cubed equals 1, which 1 equals 1, therefore it works. This is not how I was supposed to do it. I wasn't meant to solve that, I was meant to prove that. That's really annoying. Okay, so what I was supposed to do, guys, I was supposed to just say x equals sine theta, y equals cos theta, plug it in on both sides, and reduce it. Why don't I demonstrate that? Okay, so I did that just dead wrong. This is how it would have worked, because I was primed. Typically, you have to use that to plug it in to solve an equation. What I was supposed to do was to just say if x is equal to sine theta and y equals cos theta, then on the left-hand side we get sine squared theta plus cos squared theta cubed. And on the right-hand side, we would have sine 6, sine 4, sine squared cos 4, plus cos to the 6. So that gives me my 1 equals, yeah, so basically just the same thing in reverse. Three sine squared cos squared. In other words, sine 6 plus cos 6 theta is 1 minus 3 sine squared theta cos squared theta, which is 1 minus 3/4 sine squared of 2 theta as required. So that's what was supposed to happen. So apologies for slightly misunderstanding the solution path there. But they're saying use the result from A to determine the minimum value of this thing. Well, even if you didn't get A, you would be allowed to use A in order to solve B. And the minimum value of that is the minimum value of this guy. So let's consider 1 minus 3/4 sine squared of 2 theta. Well, that has a minimum when, now also this is 1 minus sine squared. So sine squared is always positive. But we're subtracting it off, right? So let's consider 1 minus x squared type graph. So we know it's going to have a kind of, we know that sine lies between -1 and 1. So sine squared lies between 0 and 1. So this is a minimum when we're subtracting the maximum. So that's when sine squared of 2 theta is equal to 1. Because that's the biggest this can ever get. So it's the most I can ever subtract. And when that happens, that's equal to 1, so the minimum is just a quarter. Okay, so now we get to the fun part. Now we get to the insert part. Now it's interesting, that's only 15 marks, so they're not as crazy because part A is 60 marks, so that really is the bulk of it. But I'm really here for section B. Now, let me show you how I interpret, and by the way, this is where the questions start appearing on the answer book. So I can get rid of the question paper entirely and just have the insert and the question paper. So first things first, I am going to read this insert. This is blind unseen, and I'll tell you how I'm reading this, what I'm seeing in this. So let's give me as much space as possible. Okay. So powers of natural numbers. The sum of the natural numbers is just an arithmetic series. The sum of the squares is given by a set formula. You can also get exact formula for other powers, not just squares. Sum of reciprocals cannot be expressed exactly in terms of n, and you only get approximates. So reciprocals are harmonic series. Okay. Euler published an approximate formula for summing, where that's that. Okay, don't know what that means yet. For the sum of squares of natural numbers gives the exact sum of the series. Good. Or this formula relates a sum of terms to an integral. For the sum of squares, this is y equals x squared. And you get 4 shaded rectangles of area. Okay. So so you do the integral from 1 to n, and then you add on a bunch of stuff. So what this is kind of saying, let's kind of now put some meaning to this using this example. The sum of the squares would be the sum of all of these rectangles. So they're saying that the sum of the rectangles is the integral, which is the area under the curve. And then we need to approximate the area of these rough triangles above the curve. So they're saying that's plus that over 2. Okay, I can't make sense of why that works. Okay, but I can apply the formula. The integral gives the area under the curve, which is smaller, so we need to add something. Oh, approximating the curve by a series of straight lines gives the 3 triangles to be added on. Oh, okay, yeah, that makes sense. Well, I see 4 triangles personally. So 2 squared minus 1 squared over 2, so half base. So that squared plus that squared over 2. Huh. This gives an approximation which simplifies. Okay, I'm not gonna lie, like that's kind of gone off. So maybe I shouldn't just be reading the answer, but I'm getting a sense of what's happening here. So also look at how I'm reading that. I don't know what this means. You shouldn't have to know what this means. But that doesn't mean I can't answer the questions. And then we've got a formula. I think I'm just going to have to use this formula. Okay, right. So I've got a sense of roughly what this is about. Okay, but let's now answer the questions, because a lot of it last time was able to be done sort of on its own. So here, evaluate this thing. Show that on line 13. So the first one, I'll do it a couple ways. So it is just 1 plus 4 plus 9 plus 16 plus 25. And that is 1 plus 4 plus 9 plus 16 plus 25 is 55. You could also have got there from saying it's going to be equal to 5 by using this formula. Times 6 times 11 all over 6, cancel, equals 55. Oh, sorry, let me just get some water, lubricate the voice. That's the problem. Excuse me, that's the problem of streaming early. And drunk enough yet. Hadn't warmed up. That's okay. All right, so show that Euler's approximate formula. Let's give it in line 13. This thing. Okay. Let's just apply this. So the sum from 1 to 5 of the function, which is r squared, is going to be approximately equal to the integral of x squared dx between 1 and 5 plus f of 5, which is 25, because the function, so I'll write it explicitly that f of r is equal to r squared. So f of n, where n is 5, so f of 5 is 5 squared is 25, plus 1 over 2, plus 1 minus 4 over 12, minus 5 minus, now f of 6, f of 5 is 25, minus f of 6, which is 36, all over 12. So that is a third x cubed between 1 and 5. 26 over 2 is 13. Hello. Minus 3 over 12 is minus a quarter. And that looks like, when all is said and done, plus 11 over 12. Because it's going to be 25 minus 36 all over 12. What am I teaching? This is OCR MEI, which is a specific A-level exam board. Their paper 3, which includes this mathematical comprehension, where they give you something you've never seen before and get you to just apply it sight unseen. So it's the exam technique of how to process the information they give you and how to apply it to the questions. So here, I'm not understanding. What are you teaching? So this is A-level math. This isn't so much teaching. This is teaching exam technique of how to. So I have no idea what this is, but we just, in this paper, you get given an insert teaching you some new math on the spot. And it's just a case of how you apply that. So you're starting a little bit late on if you just arrived. But I'm right now taking this formula that I've never seen before. Okay. So I'm taking this formula that I've never seen before and just trying to use it to answer a question. So I can't teach it. I don't know what I'm doing, but they gave me a formula, so I'm just using it. That's the trick, is applying brand new formulas on the spot. So I'm kind of just working it out. I know as much as you do at this point. So that's a third. Now I plug the 5 in. Cool. So it's a third times 125 minus a third times 1 plus 13 minus a quarter plus 11 over 12. So it's 125 over 3 minus a third plus 13 minus a quarter plus 11 over 12. And that is, when I put all that together, minus 1 over 3 plus 13 minus a quarter plus 11 over 12. So that is going to be 55, which is the same as before. So the next question says, with the aid of a suitable diagram, show that the three triangles referred to in line 26. So what is that? With the aid of a suitable diagram, show that the three triangles referred to in line 26, line 26, have the areas given in line 27. So in other words, they want me to prove that this follows on. Okay, so by approximating the curve by a series of straight lines gives three triangles to be added on. So okay, so let me piece this together then. The integral gives the area under the curve. This I know. The area under the curve is the integral. It is clear that the integral is smaller, so something needs to be added to the integral to get the same answer as the series. I agree. The rectangle for 1 squared needs to be added on. I'm not sure why the entire rectangle needs adding on, because that's already been counted, but okay. And so do the parts of the other three rectangles that are above the curve. Okay, so what they want me to do, therefore, is to approximate these as triangles, find the areas of those triangles, and add them on as required. So why don't I start there? So with the aid of a suitable diagram. All right, well, let me draw my suitable diagram, which would be the x squared curve. And then we've got our rectangles. Something like that, 1, 2, 3, 4, where that's x and that's y. So this triangle here, and now in the real thing, I would do this with rulers. So this height here is 4 minus 1 is 3, and that width is 1. That height here is 9 minus 4, which is 5, and that width is 1. That height here is 16 minus 9, which is 7, and the width is 1. So the three triangles will have, so the area of the three triangles will be a half times the base of 1 times the height of 3, plus a half times the base of 1 times the height of 5, plus a half times the base of 1 times the height of 7. So that is 3 over 2 plus 5 over 2 plus 7 over 2, which is 15 over 2. Okay, so that is the area of the three triangles. So I have to show that the three triangles referred to, I've done that, have the areas given in line 27. Well, let's look at that. What is line 27? Oh, I did that. That's what I did. Because that's where that 3 comes from. That 3 is the 2 squared minus 1 squared. That 5 is the 3 squared minus 2 squared. And that 7 is the 4 squared minus 3 squared. All the widths are 1, and they're all a half. So in fact, what I should do, let me come back to here. Okay, so that wasn't as bad as I thought. So getting the areas of these triangles, that is 2 squared minus 1 squared. Well, a half, how would I write this in the real thing? I would say that is a half times the base times the height of 2 squared minus 1 squared. I would then add on. So that's the area of that triangle. So if I call that A1, A2, and A3, that's A1, which is just 2 squared in fact, let me write that over here. So that would just be 2 squared minus 1 squared over 2. A2 is a half into 1 into 3 squared minus 2 squared, which is just the 3 squared minus 2 squared over 2. And the A3 is a half of the 1 of the 4 squared minus 3 squared, which is the 4 squared minus 3 squared over 2 is required. Okay, good. So I've done that. Prove that Euler's approximate formula, when applied to the squares, gives exactly this thing, as given in line 13. So that's this one. So prove that this one, when applied to, so I'll say f of x is equal to x squared, and let's apply that now. So the sum from 1 to n of the r squareds is going to be approximately equal to the integral of x squared from 1 to n plus n squared plus 1 squared over 2 plus 1 squared minus 2 squared over 12 minus n squared minus n plus 1 squared all over 12. Well, that will be a third x cubed between 1 and n. It'll be n squared plus 1 over 2 plus, well, rather, 1 minus 4 is minus 3. Minus 3 over 12 is minus a quarter. Minus, and I'm going to bracket this off, so that's n squared minus n squared plus 2n plus 1 all over 12. Okay. So then this will be n cubed over 3 minus a third from the integral plus n squared plus 1 over 2 minus a quarter minus, that cancels. We get minus 2n minus 1 all over 12, being really careful not to do a sign error. So that's n cubed over 3 minus a third plus n squared over 2 plus a half minus a quarter plus 2n plus 1 over 12. Now I want to show that that equals this guy. So let's bring I'm going to split everything out. So n cubed over 3 plus n squared over 2 plus n over 6 are all my n parts. And I got that n over 6 by splitting this out. So it's 2n over 12 plus 1 over 12. And 2n over 12 reduces to n over 6. And then I've got all my constant terms. So it's n cubed over 3 plus n squared over 2 plus n over 6. Now, bringing those constant terms together, it's minus a third plus a half minus a quarter plus a 12th gives me 0. So now let's bring this into a common denominator, combine the fraction. So getting everything over 6, this would be 2n cubed. That I need to multiply by 3, and that n is just by itself. I can factorize out an n and get 2n squared plus 3n plus 1 all over 6. And then I'm left with n plus 1, 2n plus 1 all over 6 as required. Good. Okay. So show that the expression given in line 33 so that's this thing. Okay, so they're saying that this thing simplifies to this thing. Prove it. So prove that this line here simplifies into this line here on the bottom. Okay, we're nearly there at the end, which is good. So prove that that is true. Okay, well, let's consider the integral from 1 to n of 1 over x dx plus 1 over 2n plus a half plus a 12th minus a 24th minus 1 over 12n plus 1 over 12 into n plus 1. In fact, no. In fact, on that one, I'm going to instead use my algebraic fraction skills to combine those into a single fraction. So that becomes n plus 1 all over n plus 1 minus n over n plus 1. Okay. Now the integral of 1 over x is just ln x. So that's ln x from 1 to n plus 1 over 2n. Let me combine all these constant terms. So I've got a half plus a 12th minus 1 over 24, which is 13 over 24. Yeah. And then I've got this algebraic fraction on the right that I need to take care of. So it's minus a 12th. And I combine those and I just get 1 over n plus 1. Okay. So I'm seeing my 12 n plus 1 forming on the bottom, and I like that. So that is ln n minus ln 1, and ln 1 is 0. Okay. I've got my plus 13 over 24. I like that. Now I need to combine these, and the way I'm going to do that is I'm going to have to make that into 12 and n plus 1. In order to do that, I need to multiply by 6 and n plus 1. So 6n plus 1 all over 12 and n plus 1 is that guy. And then that's minus 1 over 12 n plus 1. N. So that becomes ln n plus 13 over 24 plus 6n plus 6 minus 1 all over 12n n plus 1, which is the thing given as required. I really do like, you have to stay so alert, right? Because you're having to work out so much stuff on the spot, piece it together. But because it's full of show that's, it's actually not that bad. So this is 34. The expression in line 34, that's this guy, is used to calculate the sum of 1 over r from 1 to 6. Show that the error is less than... Okay, so let's get the true value. So the true value is 1 plus a half plus a third plus a quarter plus a fifth plus a sixth. And in fact, I will bring my calculator in at this point to show you how I would do that. So 1, I can't be bothered to draw all of the fractions, so I'll just say 2 to the minus 1, 3 to the minus 1, 4 to the minus 1, 5 to the minus 1, 6 to the minus 1. Okay, so the true value is 49 over 20. The approximate value is going to be this when n equals 6. So the estimate is going to be ln 6 plus 13 over 24 plus 36. Well, I'll just plug it in. So 12 times 6 times 7. And in fact, it'll be faster if I do this by hand. So ln 6 plus 13 over, 13 over 24 plus 36 plus 5 all over 12 times 6 times 7. So that is apparently 2.41477 of 532, this thing. So that's my estimate. Now the percentage error is the difference over the actual times 100. So the error, now this value, 49 over 20, is 2.45. So that's the bigger one. So I'm going to say it is 2.45 minus 2 point nonsense. So the difference over the actual times 100. And that $2.414775342. So that difference over 2.45 times 100 is 1.44%, which is obviously less than 1.5%. And that is me done with the paper. End of questions. Okay. So the first thing I'm going to do, as always, is just to make sure I've answered every part of every question. Great exam technique. So yes, this to be, that was, yeah, from below. Okay, cool. Answered every part of every question. It's looking like I did. Okay. Right, let's begin the checking technique. So here, this should be nice and simple. What we can do is to say, is just to solve it. So inverse sine of 2 over root 13 gives a value, but I want the obtuse angle, so I want to do 180 minus that. And I want to find cos of that. And I want to, in which case, that should be equal to this thing. So if I add on, so if that equals minus 3 root 13 over 3, if I add on 3 over root 13, I should get a clean 0 or thereabouts. Great. So I got the right value. It is negative 3 over root 13, which is 3 root 13 over 13. Good. Printed area, draw, sketch the modulus. I did that. Solve the inequality. I think I did that. So x values I seem to want between 1 and 4. So if I plug in 1, I would get 3. If I plug in 4, yeah, and values in between, for instance, 0. Oh no. I got that wrong. Why did I get that wrong? Because if I plug in x equals 0, the modulus of that would become modulus of 5, which is not less than 3. Because 0 is not in that region, Patrick. Come on, do better. All right, so let's plug in, for instance, x equals 2. So when x equals 2, 5 minus 4 is 1. That modulus of that is less. So things in that region, yeah, that seems like a good region. This one, I'm just going to plug my value of k back in. And remember, if these things are supposed to be equal, then if I move this thing on the right to the left-hand side, I should get clean 0. So 1 over root 5 plus root 6 plus 1 over root 6 plus root 7 minus 2 over root 5 plus root 7. Not a clean 0. Something went wrong. Interesting. Okay, so 1 over root 5 plus root 6. So multiply by top and bottom by the sign change. Root 5 minus root 6 over minus 1. Flip the sign. That. Good. Let me check my individual parts. So 1 over root 5 plus root 6. If I subtract root 6 and add root 5, I should get clean 0. And I do. Good. So let me check this next part. 1 over root 6 plus root 7. If I subtract root 7 and add root 6, I get clean 0. So that is correct. If I add these together, the left-hand side is root 7 minus 5. So minus root 6 plus root 6 cancels minus root 5. So the left-hand side should be that. The right-hand side, I'm not sure I disagree with what I did, though, is the thing. Did I get this wrong? Hold on a minute. 1 over root 5 plus root 6. Maybe a plus? Maybe I just mistyped. Like, I don't see how I did this wrong. Yeah, I agree. And 2 over root 5 plus root 7 is the same thing. Okay, so I did get it right. I don't know what, I must have mistyped something. So I get root 7 minus 5 on both here. So k is 2. I think I'm good. Okay. Find the coordinates where these things cross the x-axis. Very simply, I will plug in my x values, make sure I get 0. So for instance, x equals 1. Let's plug that into the curve. So answer cubed minus 2 answer squared minus 5 answer plus 6 is 0. So 1, 3. So answer cubed minus 2 answer squared minus 5 answer plus 6, 0. And minus 2. So I always use this answer method for substitution just to make sure I don't make any calculator error. 0. Okay. Just out of curiosity, I want to try this again. This is bugging me that I didn't get that. I'm stubborn. Plus root 6. If I add on to that, 1 over root 6 plus root 7. Then I subtract off from that 2 over root 5 plus root 7. It's supposed to be clean 0. It is. Okay, so I don't know what I did wrong the first time. Great. So these are all correct. Okay, so 5. This will also be nice and simple. We can just differentiate in the calculator. So the differential of x cubed minus 5x squared. So the fact that they say you must show detailed reasoning means in all of these cases, you can simply do it on your calculator to confirm that you're correct. So that plus 6x at x equals 0, the gradient is 6. Good. And it goes through the origin. Yes. So let's do the same thing at x equals 1. We get a gradient of minus 1. The reciprocal gradient is therefore 1. Does that go through this point? Yes, it does. Good. Those are the correct lines. The coordinates of the point of intersection. We just ensure that these coordinates lie on both lines. So they clearly lie on this line. And they also clearly lie on that line because a fifth plus 1 is 6 over 5. So those are the coordinates of the point of intersection. And that's good. This, I got it right. Like, the end. I'm not redoing that. Mainly because like I'm really confident on this one. Because of part 2, really. By looking at what happened going between the various points. So there to there is plus 10 over, it's plus 5, plus it's 5.5. Going from S to R is also 5.5. Going from Q to R is minus 3 over 2 and 3. And going from P to S is minus 3 over 2, 3. And this, yeah, I'm just really happy with that. So the opposite sides are equivalent vectors, so they're parallel and equal length, therefore parallelogram, feeling good. Show that, I did show that, verify, like I'm happy with how I did my vectors. Now 7, I'm also very satisfied with. I love a good optimization problem. So determine the max area. Why don't I... Okay, so that is, let me just make sure my 5x minus x squared. Let me make sure the gradient does equal 0 at 2.5, and it does. Did I set this up correctly? 2r. Actually, the best, hold on, let me make sure I set this up correctly. So 2r plus r theta equals 10. Good. So that is a correct rearrangement of theta. I plugged that in. The r's canceled, and that became 5 minus 2r. So it became 5. I agree with this area formula. I agree with differentiating, setting it to 0 and getting r. 2.5 equals, that's r. So 5 answer minus answer squared does give me 25 over 4 as the maximum area. And you show that it's a maximum. I differentiate, I get minus 2. That is less than 0. That's good. Okay. 8 is when things got fun. So circle center A has radius 8. Good. Center C has radius 12. Good. That split this into 2 triangles, each of 30. Can I prove that? Well, yes, because they have the I know that these are congruent because they share the length AC, and the other 2 side lengths are both 8 and 12. Therefore, these are congruent triangles. Therefore, they do have equal area, and the area of that triangle is 30. Good. So 30 equals half AB sine C. Let me just, so half a, actually what I can do is to use that side length. I can put both side lengths back in and make sure the area does give me 30. No, because that would just be doing it backwards using the cosine rule. So that really is just a case of kind of redoing it. Is there a fun way to check this? Not really. So it's just a case of just confirming I didn't do anything silly. So half times 8 times 12 is 48. So 30 over 48 is 5/8 for sine theta. Root of 1 minus answer squared. So it's plus or minus root 39 over 8. I like that. Okay. So that's cosine theta. Okay. Now, this thing is, so let me do 8 squared plus 12 squared minus 2 times 8 times 12 times answer, because the answer was cos theta. And then square root that thing. Good. Now, if I put in minus root 39 over 8 and do the same thing, the square root of 8 squared plus 12 squared minus 2 times 8 times 12, answer, I get 18.92. Good. So those look like my two values for the length of A, which I'm satisfied with. So here, 9, put in 0, you get 0.3 megawatt hours. So again, what I was doing before, let's put this in units. Megawatt hours. So T equals 9, plug that in. Let me just confirm that. 0.3 E to the 0.5 times 9 does in fact give me that. Okay. Give a reason. I hate wordy ones, but it predicts infinite growth, which is unrealistic. You get this instead, which is close to your true value. Sketch the gradient function. I think I did. There's a maximum somewhere in between. I don't really know what they're going at for D3. I think it's, yeah, so it's when it begins to increase with a decreasing rate. And state the long term is 300. Okay. I definitely did show that in A. Now 10B. So the minimum value of the thing on the left equals the minimum value of the thing on the right. So the minimum is when I'm subtracting the maximum value, and the maximum value is 1, so it's a quarter. Like, I'm satisfied. Okay, then we get into the insert. Evaluate that. So 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared is 55. Show that Euler's formula gives the exact value. Well, I did. With a suitable diagram, show that the areas, well, I did. This is the thing I really like about this part. Prove that this thing gives me that. Well, I did. Show that this thing equals this. Well, I did. And then here, show that I did. So this is the beautiful thing with these ones. Because it's so conceptually challenging dealing with the new information, it's lots of show that's. They don't expect you to just derive stuff from nothing. They always give you the answer you're looking for and just sort of make sure you can weave your way towards it, which I find quite fun. So with that said, there's nothing really to check here because I'm pretty sure I got those all right. So now it is time to mark and see if I did anything silly, or if I just didn't do the worded questions very well. So Let's check the marking. Excuse me. Okay. -3 over root 13. Yep. Yep. Between, yep. Okay. K equals 2. I agree. Full coordinates given, exactly as the question asked. Y equals 6x. Y equals x plus 1. Yep. Got the coordinates right. Half 1, 5.5, 0.5. 4, 3.5. Yeah. These are good. How did they do this? Good. So they got the vectors as well and showed that they are equal vectors and then argued. Yeah, convincing completion. Just, yeah, the opposite sides are parallel and equal length, therefore parallelogram. Okay. So here, yeah, not just parallel, but they are equal. Not just parallel, but they are equal. Good. Max is, so I see they seem to like decimals over fractions, and I just wildly disagree with that philosophy. But yeah, they did it the same way. So it's an optimization problem. You form your two equations. You make the unwanted variable the subject of the unwanted formula. You substitute in, differentiate, set to 0. So here, 7 point. Yeah, this was wild. Yeah, perfect. Really fun that. So 0.3 with a unit, 27 with a unit. Oh, extrapolation. The model's only. Okay. Or hold on. The limited growth in solar energy, so it's not possible. Okay, yeah, I went with that one. It was important to note, actually. Let's go back to 9b. So here, it's based on the period from 2000 to 2009. So with a model, it models the data that existed then. So it's good for interpolation within that time frame, but is not reliable necessarily when extrapolating. So that's a very good point and worth bringing up. So because the model is based on data only up until then, it can't really be reliable out to 2025. Value close to, yeah, gives a value close to 27 when t equals 9. Good. So you get some sort of thing like this. Gradient increasing. Yeah. Why would it be 14? Answer in the range 13 to 15. So I got that wrong. Why did I get that wrong? I assumed it was symmetric. Is it not? Maybe because it, so it does go out to 25. I assumed it would just be an average. It seems like it's not. Oh, that's why. That's what I didn't see. That was sneaky. So this is kind of flat for about 2 squares, and this is kind of flat for about 4. So actually, I should have done the average of 23 and 4. And if I do the average of 23 and 4, you get 13.5, which would have worked. So actually, it wasn't as simple as just assuming it's perfectly symmetric. I think you kind of have to see, well, because also a point of inflection happens where there's a maximum gradient. So I should have done that by eye and seen that it's kind of in this 13.5 region. So that is kind of on me. It's clear that the grade, yeah. So I deserve that loss. Okay, fair enough. Now interpret the significance. This is when the rate of increase is greatest. Right, and that's kind of what I just said about how to find an inflection point, which where there's the maximum gradient. Okay. So apologies for my lax interpretations, team. But at least you've seen the mark scheme, so you know what they wanted. Now, so they found this. So they showed that both the left-hand side and the right-hand side converge onto this value. There's just lots of ways of getting there. I did it the complicated way, and I apologize for that. As you can see, by just like, bam, But yeah, it works. Minimum is a quarter for exactly the reason I said. Then 55. You run it through, you get 55. Exactly. Um, yeah, good, good. So this, you run it through and you get it. This, you run it through and you get it. This, you run it through and you get 1.44%. All right, so just a couple of things wrong there in terms of my interpretation of what a point of inflection means. It's where you have the maximum gradient. Also, not being careful enough with that graph to find that point of maximum gradient. But apart from that, this was a good clean run. I think the best part of this is to do that comprehension where you can see in probably the earlier stuff, I'm like, all right, you do this, you do this, you do this, blah, 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 blah. And you can see that complete gear shift when I enter the insert bit where I'm like, what is this? And I have like that, and I do that, and then I do that, and I just sort of like work a lot harder to keep my core and not wobble and not fall off. And that I think is very helpful to try and emulate, to pick up and use that frame of mind. Because you can see I didn't know any of that. This was me making sense of it on the spot and making good use of the fact that there were all show that questions to try and like navigate my way towards the answer I knew I was trying to arrive at. Kind of gives me some clues on how to manipulate the algebra to like massage out the correct answer. So this is just a very, very fun paper, and I'm happy to keep doing this for the people who need it going into the rest of exam season for the final few weeks. I'm happy to leave it there. And also the fact that they're so much faster than the Edexcel papers. The fact that I can churn that out in like an hour and 40 minutes is solid. So yeah, I'm gonna keep doing these for the next couple of weeks, I think, just so that they're covered. And in the meantime, I will see. When am I going to see you guys next? Yes, I can do a debrief on Wednesday at 4 p.m. for those who want to discuss, do a little debrief on the physics and the math one. So that'll be good fun. That'll be sort of 4 till 5. So I look forward to seeing you then. In the meantime, keep working hard, guys. Have a good one. See you next time. Thanks. Bye-bye.